Soldering complex PCBs, especially those involving high-density RF circuits or surface mount components, requires a shift from joining wires to precision engineering. When dealing with multi-layer boards or tight footprints, thermal management and stability are your biggest hurdles. Here is a guide to mastering the art, including how to use clay as a secret weapon. Standard hardware store irons won't work well for modern PCB work. You need tools that offer thermal recovery, that is, the ability to stay hot even when the board sucks heat away. Temperature controlled station. Use a station with a digital readout. For lead-free solder, you will typically work around 350 to 370 degrees centigrade. The chisel tip. Avoid the needle-thin conical tips. A small chisel tip has more surface area, allowing faster heat transfer to the pad without overheating the component. Even if your solder has a rosin core, extra flux is mandatory for complex PCBs. It cleans the surface and helps solder flow into tight vias instantly. A via, short for vertical interconnect axis, is a small hole drilled into a printed circuit board that is plated with metal, usually copper, to conduct electrical signals or heat between different layers. For SMD and complex work, use 0.3 mm or 0.5 mm diameter solder. It gives you much finer control over the volume of metal added. Of course, most of these are quite costly options. The clay technique was mentioned by one of the viewers. In complex builds, components often won't stay put, and standard helping hand clips, which I have shown earlier, can't reach the center of a large PCB or might crush delicate parts. This is where non-conductive poster putty like mounting clay becomes invaluable. Place your component like a multi-pin header or a small IC into the PCB holes. Press a small pea-sized amount of clay over the component on the top side of the board. This nails it to the PCB. Turn the board over. Component stays perfectly flush against the board even if it's heavy or awkwardly shaped. Solder the pins. The clay won't melt at these distances and it leaves no residue. For heat-sensitive parts, a larger blob of clay can act as a temporary mild heat sink. That's a disadvantage. For multi-pin components like a large connector, don't try to solder everything at once. This was specifically mentioned in the ECBTEX manual. Apply flux to all pads. Put a tiny dab of solder on one corner pad. Slide the components into place while heating that one pad. Once it's straight, solder the opposite corner. Now the component is locked and you can flow solder into the remaining pins. This is what I followed when I soldered a large connector meant for the DDS VFO. Complex PCBs often have large copper regions for grounding. These act like heat sinks, making it hard to get a good solder joint. If you are struggling, use a dedicated PCB heater or a hot air gun set to low 100 degrees centigrade to warm the entire board before using the iron. Give the iron an extra second on ground pads to ensure the internal copper layers reach the correct temperature. On a dense board, a bridge, solder jumping between two pins, is your worst enemy. Use a magnifying glass or a digital microscope to check for solder bridges. Look for cold joints, dull grainy appearance, versus good joints, shiny concave fillet shaped. Of course, the picture which I am showing was done from the manufacturer, Mayon solder, most of them will be the other way around, dull grainy. So it's what we call as dry solder.